Hello everyone, I'm Swati. I work with the Nature Conservation Foundation, an NGO based in India. I'm working with Season Watch, which is a citizen science project monitoring trees in our neighborhoods. I'll be talking to you about that today. And hopefully by the end of this talk, I'll convince you to join Season Watch and thousands of others and become part of this community of citizen scientists that are helping us understand our trees better, helping us understand how our trees are changing with the changes taking place in our climate. So let's get started. So yes, so like I mentioned, we'll look at why watching trees is important in this talk, and we'll also look at what this can teach us about seasons and changes in our climate. Let's begin with the tree. This, as many of you are familiar with it, is a ghost tree, also known as Kulu in India. It's easily identified because of its bony white bark, especially in the older trees. And as you can see on the picture on left, it's leafless, and it remains leafless for nearly 6 months in a year. So it sheds its leaves in winter, and then by May, June, it produces a new flush of leaves. And so you can see here that the tree is covered in leaves. During the time when it sheds its leaves, it also puts out flowers. And soon after, sometime around March, April, these flowers become these beautiful pink fruits. So flowering, fruiting, shedding and appearance of new leaves are cyclic events in a tree's life. That is, they happen repeatedly. And study of these events is known as phenology. But how do trees know when to flower, when to fruit, and so on? So trees are, as many of us know, are experts at reading their environment. So they can look at clues such as what are the daily temperatures, what's the day length, how much moisture is available in the soil, what's the rainfall, and these environmental factors help trees in planning their lives. So, like I said, that there is a complex relationship between trees and their environment. And there is also a complex relationship between trees and the animals that are dependent on them. So by looking at how trees are responding to the changes in their environment, we can also understand how these changes have some downstream effects on the animals that are dependent on these trees. And therefore, it's very important to start looking at trees. So here is a species of tree known as pedunculate oak, and this tree puts out fresh leaves during springtime. The fresh leaves of this tree are eaten by the larvae of the winter moth, and these larvae are in turn eaten by the growing chicks of this bird known as great tit. So what has been observed lately is that the oak is starting to put forth new leaves earlier than it used to. So there's a change in the time when the new leaves appear, and the caterpillars are also changing their life cycle and appearing early in time to feed on these young fresh leaves. While that's good news, what's bad news is that the chicks are still developing at the time that they used to. So the birds are still nesting at the earlier time, and so they haven't yet synced their life cycle with the life cycle of the winter moth larvae. So as a result, these chicks do not have enough food available during their development, and they're going hungry. So this is a simple example to look at how changes in our climate are not only confusing and affecting trees, but they're also affecting the animals that are dependent on these trees. And because of this reason, it is very important to look at trees to understand climate change. So, but understanding climate takes a long time. Climate change takes a long time. Understanding how it affects tree phenology takes patience. So, but it has been done. And so let's look at one very interesting story from the city of Kyoto in Japan, where people have a special reverence and love for this tree known as the cherry blossom. So cherry blossom flowers in around springtime and puts out these beautiful pink flowers, and gets like the whole tree gets covered in these beautiful flowers. And Japanese people go out and look at these trees and sit under them, spend time with their family. So it's like a big event in their lives. So this tree, because it's loved so much, people have taken a lot of pains to understand when it flowers through hundreds of years. So for some 1200 years or more, people in the city of Kyoto have kept records of flowering time in this tree. And scientists are now using that information to look at how the patterns in cherry tree flowering may be changing. So here you have all the hundreds of years of information that was collected by people who are non-scientists in the city of Kyoto on flowering in cherry trees. And you can see that for most part of the history, the cherry trees are flowering between 10th and 20th of April. And only in the last 50 or 60 years, they are beginning to flower earlier, and now they are flowering between 1st and 10th of April. This shows that we need long-term data to understand how changes in climate are affecting our trees. And this cannot be done by a single person. It's an effort that requires a community of people to join hands. And this is where we come to citizen science, project and initiatives. So the next example is from a citizen science project known as the USA National Phenology Network, or USA NPN, where people are looking at leaf out, or when fresh leaves appear in some species of shrubs and trees. So in this map, across the entire United States of America, we can see the time when the leaves appear in spring. So the red color depicts when the leaves appear early, then they are expected to, and the blue depicts when they appear later than they are expected to. So in all these areas, southeast, most of southeast of the continent, the leaves are appearing as early as 20 days. And in most of the upper north, and Midwest, the leaves are appearing later, as late as 20 days. So with this example, we see how using a citizen science approach, we can collect data on a large scale and use the data to understand changes in tree phenology, such as leaf appearance in this particular example, across an entire country. Now this brings us to a citizen science project known as Season Watch in India. So this is a similar citizen science project where citizen scientists are gathering information on changes in tree phenology in India. You can visit our website, which is it's been updated, and this is a new website which got released just a few days ago. We also have an Android app and we started in 2010, so we finished 10 years this year. And we have nearly 4 lakh observations in our database now, from nearly 88,000 trees that have been observed by 1100 individuals, and nearly 1100 schools in India. So you can look at this map. All the balloons are the locations of the trees that have been observed. The red balloons are the trees that were observed by schools. The yellow balloons represent trees that are observed by individuals. So individuals and schools are two kinds of participants. In schools, children, they collect data and mostly note it down in their notebooks, and then this data gets digitized by their teachers, who use our website to upload it to the Season Watch database. Individual participants, they observe trees around their offices, on roadsides, in city gardens, and so on. And most of the times they directly have access to an Android phone and use our app to upload their observations. Now let's take a look at what it is that the participants are observing, how are they noting down this observation, and how are they uploading this information to Season Watch. So first of all, to participate in Season Watch, you have to register yourself as a user. You can register yourself either as a school or as an individual user. The process is very simple and quick, and you can register using our website or app. Once you have done that, now you have to start looking at a tree and recording its phenology with Season Watch. So let's look at the process of how the data is recorded. So first of all, one selects a tree. So this here, let's take an example of a Palash tree, Butea monosperma. This tree is in full bloom. And so this is the species that we are selecting. So you go to the app and you choose your species from the list that is already available. So at present, we are monitoring 130 plus species that are commonly found across India. So you choose the species from that list, and then you tell us where your tree is located. So on the map, you provide a location for your tree. Once you've done that, you give a nickname to your tree. Now this is interesting because children especially, they love giving nicknames to their tree, and a lot of time they use their fictional characters from Harry Potter that many of them seem to like. And after that, you tell us where the tree is located, some broad habitat of that tree, whether it's on roadside, whether it's in campus or garden or park. And then there are some other optional details that you can provide, such as what is the height of the tree, what is the girth of the tree, but these are optional details. Once you've done that, you added your tree. So this information about the tree is submitted only once, recorded only once, and now you can start observing your tree regularly. By regularly, I mean ideally once every week. So once every week, you go to your tree and then you look at the tree, and then you record which phenophases are present in this tree, and you try to quantify those phenophases. So what are the different phenophases that one looks at? Here is a list. So a participant will look for fresh, mature, and old leaves. They'll look for buds and open flowers. They'll also look for unripened, ripe fruits. So first of all, we look at which of these are present. So in this example, we can see that there are some flower buds and there are open flowers. The other phenophases are not present in this tree. Once we have figured out which phenophases are present, we have to provide a count or some kind of quantification of these phenophases, which is done very simply as whether it's few or many. Now, how to decide between those two options? We imagine the crown of the tree as a sphere, and then we divide it into three equal parts. So if the phenophase is present in only one part, we count it as few. But if it is present in more than one part, then that is recorded as many. So in this case, we see that the buds and flowers are present in most of all of these parts of the sphere. How do we note this onto our app? So we provide an observation date for our observation. These are the icons for the different phenophases. So we haven't observed any fresh, mature, or old leaves. So they're all marked as none. We are seeing many buds and many open flowers, and we haven't seen any unripe or ripe fruits. So all these phenophases are marked and the observation is saved. This takes hardly 5 minutes of your time. So I will encourage all of you to go out there and pick a tree that you would want to observe and start observing it right away. Now let's look at the data that's coming into Season Watch. Which are the species that are most observed by our season watchers? These are the top 4 species that are loved and most observed. So first is jackfruit with more than 50,000 observations. Then is mango, more than 45,000 observations, followed by tamarind and amla. Now you'll also notice that all these 4 trees are beloved fruiting trees, and therefore it's no surprise why people, are going out and watching so many of these trees. So now the data has come. What can we learn from the data? So let's take an example of mango tree, since it's one of the most observed among most observed trees in Season Watch database, and try to understand the pattern in its flowering and fruiting and when the leaves are present on the tree. So since the data is collected weekly, x-axis shows time in weeks, and y-axis shows percentage of trees having all these phenophases. So you can see that the flowering reaches its peak, which is shown by this hump in the 13th week of the year, which is in March. The flowering is quickly followed by fruiting, which is happening a little later, and this peak happens to be falling in April-May time. Now, why is the fruiting happening in April-May? Well, it's because most of this data is coming from Kerala, and the trees in Kerala happen to be fruiting during those months. But what's happening in the rest of the country in mango trees? When do mango trees fruit in the rest of the country? So to understand that, we carried out some events which were happening on like 4 days, short events, when we asked people to go out and look at as many trees as they could. So here you see the first event happened in December 2018, and gray color dots show all the mango trees that were observed during that event, and the highlighted ones in yellow are the trees that were fruiting. So you can see that fruiting is restricted to Kerala in December 2018. The next event was in June, and in June, again, people went out and looked at trees, and we see that, yellow dots appearing like light bulbs in the rest of the country. So the fruiting has spread to most of the country, and we observed fruiting in more than nearly 45% of the trees that were seen. A few months later, in September, the fruiting is mostly again over, and hardly any trees are fruiting, and those that are, they are restricted to Kerala again. So the fruiting event is over. So with these two examples, we see that we can see how the phenology of mango changes in a year, how the fruiting, flowering, leafing patterns change in a year through time. But we also were able to see how the patterns change from one place to another. Now, what is of interest is whether we can start detecting changes in these patterns. So that brings us to this last example, uh, which is of Indian laburnum, known as Kanikona in Kerala. So in the state of Kerala, people celebrate this festival uh, it's the Kerala New Year festival known as Vishu. And it happens to be in mid-April. People go out and collect flowers, these beautiful yellow flowers from the Kanikuna trees, bring them home, and then they use them as decoration, and they look at it, and that's part of the festivities of uh, this time. So because of this close connection between the festival and the flowering time in the trees, people were noticing that something is not well with the trees. They were finding it very, very difficult to find flowers during the festival. In fact, sometimes they had to buy these flowers, something very unheard of in the early days. People had to use plastic decorations at times because flowers were not available. So when this concern came from our citizen scientists, we thought, why not look at season watch data for the species to see whether there is some change that is happening and whether we can detect it. So in this graph, we plotted all the trees that were in full bloom in Kerala between 2015 and 2018. So 4-year data, and the red vertical lines mark the week of Vishu. So we can see that especially here and here it's more clear that the peak flowering is happening just before the Vishu week. So indeed what people were noticing, that there is some change happening in the flowering time seemed to be true, and it was supported by the data. But let me also quickly mention that this data is only for very few years, and we've seen from previous examples that of cherry blossom and from the USA NPN that we need long-term data to really understand these changes better. But this is a start, and going forward, we would like to do this for many more trees. So we know that flowers of Palash have a special significance, and they're also culturally important because they're tied to the festival of Holi in North and Central India. Similarly, flowers of Neem have a special significance in the celebration of New Year festival in Karnataka and Tamil Nadu. So hopefully going forward in the coming years, we'll be looking at data from many more species, especially those that are of cultural importance, where we know of some reference point from which we can compare changes in case these changes are taking place. So thanks a lot for listening to this talk. If I would really encourage you to join Season Watch, look up our website seasonwatch.in, and I hope you can join and start looking at trees. If you have any doubts, questions, queries, please feel free to contact us on sw@seasonwatch.in. And thanks so much for listening.